Hi, everybody. So go ahead and read the question. You can pause this video. Basically, it says the International Olympic Committee states that the female participation in the 2004 Summer Olympic Games was 42%. That 42% is the claim. Okay, so that is a parameter that is from our population. Even with new sports such as weightlifting, hammer throw, and modern pentathlon being added to the games, broadcasting and clothing companies want to change their advertising and marketing strategies if the female participation increases at the next games. An independent sports expert arranged for a random sample of pre-Olympic exhibitions. The sports expert reported that 202 of the 454 athletes in the random sample were women. Is this strong evidence that the participation rate may increase? Test an appropriate hypothesis and state your conclusion. Test at a 5% level of significance. All right, so let's pull out the important information. So as I mentioned in the beginning, the 42% right here, that is a population claim. In other words, that is our P. So our P equals 42%. And we can pull out our sample, which is our P hat. And that is reported as 202 out of 454. So I'm going to go ahead and write that down. Now, when you are performing a hypothesis test, it basically is very similar to what we have been doing, only we're going to add one additional item, and that is a hypothesis. So let's take a look how we're going to start this problem. So the first thing we're going to state is a hypothesis statement. Now, what is a hypothesis statement? We're going to have the null hypothesis, which is my H naught. The H naught is basically the claim that we read in the beginning here. Okay, the claim is that female participation rate in the Olympics is 42%. So the null hypothesis is always going to be an equal sign or just no change at all. So we are going to assume this is true. Now, our alternative hypothesis, we pull that out from the problem. It says, is there an evidence that participation rate may increase? Increase means that it could be more than 42%. So that will be our alternative hypothesis, which is HA. So we're going to say that P is greater than 0.42. Now, please be careful. In your hypothesis statement, you always put a parameter, never a sample. Remember, we are trying to estimate the population, so we never put a sample in a hypothesis statement. So be sure to always put your parameter here. So notice the symbols I have is P and not P hat. We are going to use this sample right here to see if we have any evidence to either go with the null or reject the null. So let's go ahead and see what we're going to do next. The next thing you want to do is what we have always been doing is we're going to state and check the conditions. So I'll let you take a look at that. It's basically number one, selected from a random sample, and it should be stated somewhere here. It says the sports expert reported 202 out of 454 were taken from a random sample. So right here, it says random sample. So that condition is met. And then you will check that NP is greater than or equal to 10 and NQ is greater than or equal to 10. Now we use our population P, never P hat, if we know our population P. So we know it's 42%, that is given. That's what we're going to use for our conditions. And the third condition is the 10% condition. And when you do populations greater or equal to 10 times N, we get that there are 454 athletes, and we have more than 454 athletes in our population. So we will say conditions met, and we will do a One.Proportion.Z test. Now I want to show you in a calculator how we could enter. So the first thing you're going to do is go to Menu, Statistics. You're going to go to Stat Test, number 7. And from number 7, what we want to do is a One.Proportion.Z test. So you will go to number 5. Now from number 5, it prompts you to enter. This PO is the same as P naught. In other words, what is the hypothesis claim? Our hypothesis claim is 0.42. So notice when we're looking at proportions, this is always going to be a number between 0 and 1. If you enter something greater than 1, you will get an error. Now, what is our sample? This is our x over n. So remember, the x over n right here is actually our p hat. And our x is given as 202 out of 454. The last thing we want to do is the type of hypothesis, the alternative. What are we going to test? Either greater than, the option is less than, or no difference. In other words, not equal to. So what the paragraph states is we're checking to see if it's more than 42%. So we're going to check a greater than. We press OK, and we get all our information here. Now, in a moment, I'm going to talk about what this means. But in the meantime, the first thing I'm going to look at is the Z value right here, and it is given as 1.07642. So we can actually use that when we are looking at our statistics. So let's take a look here at our mechanics. The formula is just like the one we used when we did chapter 5 for normal distribution. So our test statistic in this case is our Z-score. Our statistic is our P hat. Our parameter is our P. And the standard deviation of the statistic is just the square root of our P times Q over N. Now we can see here are our numbers. Our P hat is 202 over 454, which is 0.445. Now, if you look at your calculator, it gave you a little bit more accurate of a P hat, but you can round up to 0.445, which is what we have over here. Minus our claim, which is our parameter, 0.42, all over the standard deviation of the statistic. So 0.42 times 0.58 over 454, and we get a Z-score of 1.09. Now our Z-score on the curve is somewhere here, which is 1.09. Now pay attention that this is also where our P hat is. So this is the Z-score that corresponds to 0.445, and we want greater than. So greater than that, we're going to check the area to the right. Now looking at our p-value, that is the area under the curve, which is given as 0.138. So we've actually calculated p-values before when we were looking at the normal curve and calculating the area under the curve. This is exactly the same thing. So our P, our probability under the curve is that P hat is greater than 0.445 is equivalent to our Z-score. So notice they're at the same spot. And that area is 0.138. Now, what do we use this information for? We basically, once we know our p-value, we're going to compare it to our significant level. Now, going up here, it says test at a 5% level of significance. 5% level of significance basically is the same as alpha, which is alpha represents our significant level, is equal to 0.05. Now, normally, unless they give you a significant level, if they don't give you one, you will default to 0.05 as your level. But they gave that as a level to test it at anyhow. So we're going to compare our p-value to that level. Now, we're either going to have our p-value is greater than the level or smaller than the level. And in this case, we have that our alpha, which is 0.05, our p-value is larger than our alpha. So the way we state our conclusion is we say we fail to reject the null since the p-value of 0.138, which is what we got here, is greater than alpha, so alpha meaning this symbol here, equal to 0.05. You should always, in your conclusion, compare your alpha to your p-value, which I did. So you must always compare these two. Now, if your p-value is greater, then you fail to reject. And then you state we have insufficient evidence that the female participation rate is greater than 42%.